Thank you. Great, so we heard some amazing talks earlier on this morning about looking back over the past 20, 30 years of virtual reality. But I'd like to just kind of cast your mind back by 1 year to last summer and remind you of a game that was released onto the market that on the very first month of its release, it generated $200 million in revenue. The days following the launch, the company that owned part of this game went up in value by $23 billion. And for those who played this game, used it more than they used Facebook, Twitter, Google Maps, or even Tinder. Now, I'm sure you can all understand or anticipating that the game I'm talking about is, of course, Pokemon Go. And although this has been hyped up a huge amount, I honestly don't think enough people are talking about the significance of what Pokemon Go had for both AR and VR. We had I met the CEO of Niantic last week, and he told us that at one point Pokemon Go was receiving more queries than Google search. It's a really big deal. And let's just have a look at I wanted to talk about the ways we currently use Pokemon Go. And, everyone's expecting augmented reality to live up to this expectation where it can replace the mobile phones in our pockets. But there are a number of different barriers or challenges that we've got to overcome before we can really push through that. So I thought it might be a good idea to have a look through. Eventually, augmented reality is going to be used by surgical professionals to be able to visualize the body in new ways. It will be used by engineers to rapidly prototype new ideas and see those ideas come to life around them. It will be used by engineers to fix machines that they've never even seen before. And the idea of having this inside our living room, having this as something that is always on, is really, really exciting. We've got each of the top 10 technology companies in the world has heavily invested into this, but we have a few challenges to get there. So what are these challenges? Let's start off with the way we actually view Pokemon Go today. Many of you who will have tried it before know that we use this on our mobile phone, and the phone acts as this sort of window into the augmented world. But rather than just looking through this window, you kind of want to get away from that. You kind of want to not just look through a window, but step through. And to do that, we need to have something which takes up our entire field of view. We need to have a head-mounted display, something which is always on, which can mix our real physical environment with the digital objects or digital content. Now, we've seen things like the HoloLens, and we're hearing discussions about Magic Leap, but actually augmented reality headsets have been around for a little bit of time. Here's one of the early. They call it a portable AR headset, but I'll leave you to decide whether you think it is.
I know exactly where I am and what I'm looking at. So when we do this, we can then augment the real world, which I am in now, with the virtual world. So this Pac-Man world, I'm seeing it as part of the real world. I can see cookies in front of me, and I'm walking through them as if I'm the human Pac-Man. So what we're aiming for is that we're taking the human Pac-Man and bringing it into more mobile devices. Within 2 years, we'll be able to see full commercial human Pac-Man type games on the mobile phones.
So that video was 10 years ago, okay? Within 2 years, we definitely did not see that going around. And you might laugh at that video now, but actually, if you compare that with the types of scenes that we saw with Pokemon, actually, there were people that were running across fields with their phones out and catching these digital objects. So it's not as crazy as it sounds. But it's really the early stages. I was lucky enough, I was in the Museum of Computing a few days ago and was lucky enough to see this headset in the flesh. This is, as I'm sure many of you will know, the Sword of Damocles, the very first virtual reality headset. We're still at this early stage of these headsets where it's similar to the early stages of mobile, where we have something which is purportedly portable, but not something that we can really feel comfortable wearing day by day. We really need to move a step further than that. It's not just needs to be portable, it's something we can feel comfortable, which means we need battery life, we need economics of the device itself, ergonomics. So portability is the first thing that we really need before this can replace the mobile phone in our pocket. So portability first. What else? Things like Twitter, Facebook, Pokemon Go show us not only how important technology is in being social, but how important it is to actually bring people together. Facebook is an incredible social tool, and unfortunately, this is an area where augmented reality has been lacking in the past. You'll remember the unsavory term that people called people who wore these Google Glass, these glass holes, because they created something which, rather than bringing people together, it created this unnatural divide between people who had these devices and people who didn't. People sort of feared this technology that sat on people's faces, and that had a negative impact on augmented reality. But thankfully, you'll probably also be familiar with another company that came onto the market with a device last year with Snap, with these Snap spectacles. Now, admittedly, this isn't an AR headset. This is just a camera embedded with into a pair of glasses that ties in with your phone. But it is the first step towards a head-mounted display that we can all feel comfortable wearing around our friends. And I think one of the best things that Snap did with this, other than not targeting the kind of techie community first, but targeting actual real people, was they made it look like, I don't know if any of you have worn these, just a show of hands, who's worn a pair of spectacles. They feel crap. They feel like a pair of 10-pound glasses that you could pick up from the corner of a store, and that's probably to its testament. You know, there isn't that unnatural divide between people who have them and people who don't. So they need to be portable, they need to be sociable. What else? Well, you know, as humans, we've got an incredible ability to recognize and react to stuff in the environment around us. And this is an area that only in the past few years that technology has really been reaching some sort of level of semantic understanding of the world. Now, if you want to overlay content onto the physical world, it's really, really, really vital to understand precisely where that user is and in which direction they're facing. You know, if you want to try to overlay something like this onto the real world, if you're out of accuracy of the location of your user by even as much as a few centimeters, it's going to have a real negative impact on the experience. So, in the past, you'll sort of be familiar with things like these. This is called an April tag. This is a little bit like a QR code that it's easy for a computer to be able to recognize with a camera. It will recognize the bounding box first of all, then we'll search inside that bounding box, and there's a little code that will tell it what to present. And although it's efficient on a mobile device, it just doesn't quite ever live up to the expectations that we really want. These 2D markers overlaying AR content just don't live up to our expectations. And I'll show you a video again. I promise I'm not using this to ridicule the creator of this. Far from it, but just to show you what people have done in the past.
I'm Brian, and today I will become Optimus Prime.
This goes on for about 5 minutes, just in this similar vein, so I won't put you through it all. But this doesn't live up to our expectations, right? We don't want anything like this. What we want is we want to have environments where we can have rich digital experiences overlaid onto the physical world. And that's what I'm really excited to tell you about, what we're doing with our company Scape Technologies. Figuring out how you can have genuine location understanding for the ordinary phone that's already in your pocket. And the way that we do that, rather than relying on these 2D markers, we build up a 3D model of the environment, such as the map of Piccadilly Circus that you can see behind me. This is all image photogrammetric map data that we essentially store up in a server of Piccadilly Circus. Now, with this map data that sits in the cloud, we can query this at any one point with any camera device, whether that's a 3-year-old mobile phone or whether that's a HoloLens today. Now, I'm not showing this model to show you the visual fidelity of this map, but this map contains all the information we need to be able to figure out precisely where within that area a user is, precisely down to the closest centimeter. And to show you a demonstration of what we've done, here's a video that we created showing our system working through a regular iPhone. So this is communicated with a server. We figure out precisely where we are. Because we've already built up a 3D map of the environment, we understand what the geometry of that environment looks like. And we can craft a scenario around that scene itself. I've got 5 minutes left, so I'm gonna move on. This brings us back to how we can make use of this. It comes back to the content. Up until this point, we've relied on overlaying 2D content onto the 3D world because the opportunities of creating 3D content have been restricted to people that are comfortable with 3D software experience. But with things like Google Tilt Brush, with these VR experiences where you can put on a VR headset and draw, sculpt, and create in three-dimensional space with the same ease of using a pen and paper, this is really the next generation of content creation that we're going to see en masse. So now you can take a Tilt Brush model, put it into augmented reality, and really make this canvas, this world your canvas. So we can't do this without you. We know that the top technology companies are invested into this space, but we need people who are willing to go out there, be challenged, collaborate, and build something, build this next future. So what does the next Pokemon Go look like? Well, I always say in my talks, if you want to have a look at where VR and AR is going, you just have to look at Arthur C. Clarke, who said that any sufficiently advanced technology is indistinguishable from magic. So if that is the case, if technology allows us to be magicians, I believe AR and VR will allow us to be gods. And once you realize that the world around you is now this wide canvas, the only question that remains is what will you create? So thank you very much. And if you've got any questions, please email me. Thank you. Do you have time for one question?
Probably got time for a couple, yeah.
Cool, brilliant.
Hello. Sorry, can you just explain again when you were showing the visualization of where was that? I can't remember. So you don't need any GPS data or anything like that.
So we can use GPS as a prior, so we're not searching an entire map. We've built up several miles now of map data within central London. So we use that GPS as a prior, so we're not searching the entire map.
So it's almost like where you're viewing is like a fingerprint particular to.
Yeah.
Okay. That's amazing. Cool.
Thanks.
Thanks.
All right. The world is kind of a big place. You're not going to scan it in its entirety. So what's the plan? I mean, what are you going to do to map more places?
So by the end of the summer, we'll have the largest 3D map for the purpose of locating a single camera device anywhere across the City of London. We have a strategy of how to get there. And we will be working with suppliers to be able to provide. We're focusing on cities first. We're not necessarily interested in going around and mapping every inch of the M1, but there could be ways we could do that as well if we wanted to.
Sorry, I'm just going to. How would you map precisely hidden infrastructures, for example?
Hidden infrastructures would be tricky.
Yeah, like pipes underground.
Like pipes underground. We're
not
necessarily looking at that right now. I mean, if you have that data, you can rectify that against an existing 3D model. So if you have data about where these pipes are, and you have an existing model of what the world looks like of the visible information, you can combine one with the other. So there's some really interesting studies into looking at, right, if you have data of an outside building and you also have data of an inside building, how can you rectify those together automatically? And actually, there are ways you can do it by looking at the windows and aligning them like that. So there are definitely ways to do that.
Ed, hi.
Hello.
Very soon mobile phones will have the ability to actually map in the same way. Are you working towards actually capturing that data from individual mobile phones?
Yep, we are. Although there are obviously privacy questions around about that. With a lot of the phones that are coming onto the market, their prioritizing things like structured light. So they're projecting out a UV pattern onto the environment, but it typically it struggles outside because of the big UV light up in the sky, so you need a slightly different approach. But we're going to have to face some questions about privacy and how much data we want to be able to provide these companies like Facebook and Google and even our own at some point in the future. But as much as what we're doing at the moment, we're abstracting that data. So we're keeping the information about the geometry and not really treating them as you treat a normal image as a human. But yeah, we are. One more.
Hi. So obviously, in a few years' time, when we have autonomous cars going around capturing all this information, the amount of point cloud data and photogrammetry data is going to massively expand, especially across cities and infrastructure. So I work in a lot of infrastructure stuff where we, instead of capturing that information, can you rectify that against a rendered bit model, for example?
Yeah.
So similar kind of applications then.
Yeah.
Cool. All right.
Cool. I think that's it. Thank you very much.